Hello, my name is Tom Teets. I am an assistant professor of chemistry at the University of Houston. So first, a little bit about myself. I'm originally from the state of Ohio, and I moved around a lot for my education. So I spent about 5 years in Boston, Massachusetts, doing my graduate work. Moved to California for a couple of years to do research before coming down here to Houston to start my independent career at the University of Houston. So a little bit about the research that my group does. We are primarily interested in luminescent organometallic compounds. So an organometallic compound is one that has a metal at the center. Usually we work with platinum and iridium as the metal, but there are many other possibilities. And then that metal is going to be surrounded by different organic groups that are primarily composed of elements like carbon, hydrogen, nitrogen, oxygen. And those organic groups that surround your metal can give the compound different properties, different functions. And the property that we're most interested in is called luminescence. This is the ability of certain chemical compounds to generate light of different colors. So for luminescence, you typically give the compound energy of one form, either one color of light or electricity, and then the compound converts that energy into a different color of light, a very specific color of light, as you can see. So the pictures behind me, these are all different samples, different chemical compounds that my group has made and has done research on. And you can see that we can cover really the whole visible spectrum, from the blue to the red to everything in between. And a big part of our research is trying to understand how to change the molecular structure to control what color of light is generated. So that's sort of one piece of the puzzle that we look to solve. The other and perhaps more important part is to understand how to control the efficiency. So to basically to maximize what percentage of the energy that we put into the compound is converted into light. Or in other words, how bright is the light that's generated by these compounds when they undergo luminescence. Now, luminescence has a lot of potential technological applications, and one of the important ones is in OLEDs, or organic light emitting diodes is the full name. So if you've been shopping for a phone or a TV recently, you've probably seen the acronym OLED, and it's a type of display technology that has become very popular and very successful, especially for flat screens like cell phones and televisions. And one of the big research challenges in developing OLEDs further is to improve the efficiency and the stability of blue OLEDs. And so the blue OLEDs that are currently in these devices today, they either have poor efficiency, which means that they use a lot of electricity and would reduce the battery life if they're in a phone, or increase the power consumption in a TV, or they have poor stability, which means that they don't last very long. So we're looking to sort of solve that problem and make some modifications that allow us to generate blue luminescent compounds that are both very stable, that means they last a long time, and that have very high efficiency, and that's a big part of what we do. In terms of how we got into this area of research, this was not something we really started by design. So I had a lot of training before in different areas of chemistry that are somewhat related to this. And when I came to the University of Houston, I was not specifically planning to work a lot on luminescent compounds, but we started some of these projects as this sort of small curiosity-driven projects in my group, and they really took off and became a very big part of what we do. And I think that's an important lesson to understand how science often works. It's not so much about coming up with ideas and carefully planning everything. A lot of what we do is just follow the different directions that are naturally presented to us when we do the experiments, when we study the topics that we're interested in. And so that's kind of an important lesson both in my own career and hopefully for you guys as well, to know that a lot of times in science it's just about following the directions that nature provides to you. In terms of advice that I would give people interested in STEM, especially students like yourselves, I think at your sort of age, being in middle school or early high school, the most important thing you can do is just focus on your studies in the classroom and try to learn the basics, because those basics are going to be very important no matter how far you go in your STEM education and career. And then also, I think once you get to college, it's very important to get involved in research. That really teaches you how STEM works. It really gets you involved in some of the cutting edge topics, and it really broadens your education, and I think is much more interesting than what you'll do in the classroom. And then finally, if I could summarize what STEM means to me in 3 words, I think the 3 words that come to my mind are creativity, collaboration, and innovation. I think especially in the type of research that we do in chemistry, creativity is a big part of it, really trying to design and come up with new molecular structures, new forms of matter that don't currently exist, and really pushing the boundaries of what is known and what is possible. I think collaboration is important because to solve any problem in STEM, you need to have input from a lot of different areas. No one person is going to be equipped to solve a big problem by yourself. It does involve a lot of collaboration with other areas. And then finally, innovation. I think when those two things come together, creativity and collaboration, that's where innovation really happens. That's where you get new technologies and things that lead to improvements in our everyday life. Well, I thank you for listening. And if you have any other questions about my research, please feel free to get in contact with me and I'd be happy to talk with you.